Alright, so here we are, 6.2, day number 2. Find the area by integrating with respect to y, horizontal cross section. Right, so what I want to do is be able to graph these two functions. Well, one of them is not a function, but I'm going to graph the two. I'm going to find out where they intersect, and I'm going to hopefully find the area between them by integrating with respect to y. So this right here is going to be easiest to graph if I have y all alone. And I'd have y all alone if I subtract 4x and divide by a negative 1. So that would be 4x minus 16. Okay, so let's sketch that real quick. That'd have a slope of 4 and a y-intercept of negative 16. Alright, so let's call that y1. y1. Okay. It's probably going to be easiest, and this may or may not resonate with you right away, but it might be easiest to graph this if we had this in terms of x, because it's not going to be a function. Right? If I have y squared, I'm going to have two possible outputs for every input. Therefore, I'm going to solve for x. That would mean subtract y squared and divide by a negative 4. So that would be x equals, well, let's go with negative 4x equals 4 minus y squared. And when I divide by that negative 4, I get negative 1 plus y squared over 4. Okay, so why is it easier to graph that? Because if y equals 0, then x has to equal negative 1. Okay, and then really it's just a parabola that is graphed sideways. So let me do this in blue. So this is the point negative 1, 0. And our goal is to find these 2 points. So how can we achieve that? Well, what I would do in this case is I would actually take this function here and I would solve for x. You'll see why in just a second. So I'm going to solve for x, so that would be 4x equals y plus 16. So x equals y over 4 plus 4. And then what I'm going to do with that is I'm going to plug that in for x over here. Okay, so I'm going to try to switch colors here. Can I switch colors? Sure. Okay. Alright, so I'm going to plug it in over there. So that'd be y squared minus 4 times x. X is y over 4 plus 4. And that's equal to 4. Okay, so if I distribute this 4 here, I'll get y squared minus y. The 4's will cancel. Minus 16 equals 4. And therefore, y squared minus y minus 20 equals 0. That's factorable. This is going to find my y values where these two functions intersect. So this will be y minus 5 and y plus 4. That means I get two values for y. I get a positive 5 and I get a negative 4. So I know that this point right here is some x value comma negative 4. I know this point right here is some x value comma positive 5. So I just need to figure out what my x's are for that. And go figure, I've got this right here to help me do that. Okay, so let's plug in y equals 5. Okay, so this will be our red value. If I plug in y equals 5, I get 5 over 4 plus 4 over 4, which is 16 over 4. Excuse me, 5 over 4 plus 4, which is equivalent to 16 over 4. So that x value would equal, looks like 21 over 4. So 21 over 4. Okay, let's plug in a negative 4 in here. So if I plug in a negative 4, it looks like x will equal negative 1 plus 4, which would be a positive 3. Okay, so I found the points of intersection. Now we just have to set up an integral in order to solve. Okay, so I want to integrate with respect to y. So what I want is I want functions where x is isolated. Okay, so I like this, and I like this. Okay. Alright, so just for the sake of colors here, I'm going to make this green so that I can see what I'm doing here. Alright, so I'm going to take the integral. Now for my y values, I'm going to go from negative 4 to 5 of my function that has greater x's, right? It's on top with respect to x. So that'd be my green function, which is y over 4 plus 4. And then I'm going to subtract my blue function, well, my blue relation, I guess. It's not a function, which is negative 1 plus y squared over 4. And that would be differentiated or integrated with respect to y. Alright, now at this point, I think the expectation was pretty clearly going to be a calculator type problem. So I would just type this directly into your calculator, and what that'll do, in case maybe some of you are not quite sure because of all of what we're doing here, all the logistics to this, we are finding the area enclosed by those two curves. Alright, that is 6.2, day number 2, integrating with respect to y.